I am going to show you an example, and what I hope you get out of the example is sometimes we talk about sides, and sides are an interval with a length, and sometimes we talk about vectors. And that's why, remember, we're reminding you to use those little tildes underneath. It's really important. If you leave off a tilde, you're suddenly into a side. If you've got the tilde, you're into a vector. So we're just going to run through really quickly the cosine rule and how it relates. And we're going to start with a generic A vector coming from my origin, which means it's what sort of vector? Good. And a generic B vector also coming from my origin. And the angle between those, which remember is always the non-reflex angle, is going to be theta. Now, when we have a cosine rule, we need a triangle. So we need to create another vector. Now, my question to you to start with is, which vector are we creating? What's it going to be called, and how can we describe it in terms of A and B? Because I haven't got an arrow on it yet. But this will need to be, if we're talking vectors, this needs to be a vector. How do we want it to be vector A, B? Or do we want it to be vector B, A? We're happy with A, B? So from A to B, this is now my vector. Yes? Now, how can I describe vector AB in terms of my A and B vectors? My lowercase a and my lowercase b vectors. What is it? A over 2AB? Someone say that?
AO plus OB, which is my...
AO plus OB. So you're coming around like this. AO plus OB. Is everyone happy with that? Just pause for a second. Everyone happy that I've got my tail to tail and my head to head? And that's really important. Yes? So we could write that as AO plus OB. Now, just a quick aside. There's where I start and that's where I end. There's where I start and that's where I end. So it's a really nice quick check. Now, AO is not what we have. We have OA. So we don't have A, we have negative A. So we can write that as negative A, or we can write it as B minus A, your choice. So we now have an expression for this vector up the top. But I just wanted to pause and make sure we're all getting our directions correct in our vectors. Now, if we use the cosine rule, what does the cosine rule tell me about this triangle? Length. It tells me length. Is length scalar or vector? Scalar. So what my cosine rule actually tells me is that AB squared, not a vector, AB squared, is equal to OA squared plus OB squared minus 2 OA OB cos theta. Are we happy with that? Notice I haven't put AO because it's a scalar quantity, so it doesn't actually make any difference. If we want to make it clearer that we're talking length, and here's a hint, we do. How do we show length? We show it by doing our absolute value, because that enforces that these are the magnitudes of these sides. So we can run it through with absolute values. Agreed? Question, Daphne?
Is the absolute value outside the square or inside the square?
The square is outside. That's my length, and then I'm squaring it. Sorry, poorly written by me. No, it doesn't make much difference. Okay, so we want to take all of these and convert them into vectors, because it's the vectors that I'm interested in. If I had this one here, this is the magnitude of vector AB. What's the equivalent, magnitude of length AB? What's the equivalent vector? Is there one? It is? It is vector AB, and we want the magnitude. Vector AB had this lovely little sign. We worked that one out earlier. So yes, this is a vector, but I've made it a magnitude so I can call on something that relates to length. For OA, what are we getting? A. Does it have to be negative A, or can it just be A? And it doesn't really matter anyway. For OB, we good so far? Now yesterday we learned a dot product. What was the dot product that we learned? What was it? A dot B we like that? It just went on. I was like, hang on a sec, it's got to stop somewhere. We can see this here. Do you agree? Yeah. So we can actually find the length of this side using the cosine rule with our dot product on the end. So we can relate them. How you choose to do that depends on the question, and it depends on what you're being asked. What I wanted to make really clear was that you have to be certain that you're talking about a vector or a length. And here, even though I have vectors in here, they are all lengths because they're all absolute values, and this is a scalar because it's a scalar product. In this question, we are given two vectors E and F, and there is an unknown in our vector F. We are told if vector E is perpendicular to vector F, calculate X. This one's a fairly straightforward application of our dot product. Who would like to have a go? And which version of the dot product are we dealing with? Make what equal to 0? Good. So if we have the vector E and the vector F, and if they're perpendicular to each other, they're not helping or hindering, so they have no or zero effect on each other. Is it easiest to do the dot product in this form, in column form? Who likes what? I find column form actually really nice for this version. Now what's my next line of working? I was going to say, Josh is like so close. 7x, Josh? Plus 15. So what's x equal to?
15 minus 7.
Easy, easy? Nice first one. Alrighty, a slightly different version of dot product. Who wants to have a go at this one and talk me through? Even if you want to just get started. Calculate the angle between these two vectors to the nearest degree. Which version are we going to use? The theta one. So we're going to have A dot B equals and we actually want to solve for cos theta. So the way I would do this is to set them out with each of the components. So can somebody, other than those who've answered, tell me what is the magnitude of vector A? Square root of? Minus 5 squared. And what's this equal to? Varshan? Root 29. What's our magnitude of vector B? 3 squared plus 1 squared, which is root 10. So I've got this one and this one. And what's my A dot B? My dot product, my scalar product of A and B.
Minus 15.
So how do we get minus 15?
Minus 5 times 3 plus minus 2 times 1.
Tell me where it comes from. We can pretty quickly go minus 17. Do you agree? So far, we've got all of the components we need for cos. To get cos, I'm going to do my dot product and divide by the product of the magnitudes. So we get minus 17 over square root 29 times square root 10 is square root 290. Now, somebody grab a calculator because I don't know that one off the top of my head. Theta is therefore going to be, it's a negative, which means it's second quadrant, which means it's an obtuse angle. 176.6. 177 to 1 decimal place. Sorry, to whole degrees. We good with that so far? So we can find the angle between two vectors. Now this is very important, not at the moment, but if we were trying to construct a building or a bridge and we had a prevailing wind direction which is coming from one direction, we have forces coming from other directions, we often need to resolve those into components and work out what the angle between them is so that we can actually work out where we need our support structures. So these sort of things are very, very useful when you're dealing with anything regarding a force. And when we get on to our application questions, you'll notice they're almost always force questions.